How you going, guys? Kurtis from Cutting Edge Engineering. Today's job, we're going to be doing some maintenance on our main lathe. There are a few things I've been putting off doing, but it's about time I got them done. We bought this lathe brand new from Heron Forbes. What it is a ToolMaster 26120G. It has a 120mm spindle bore in it, 3.3 meters between centers, and a 600 swing. A lathe this size is perfect for the work that we do. We've had this for 8 years, and it does get used every day. We've definitely put a lot of hours on this, and by the look of it, it really needs a tidy up. So obviously the lathe needs a really good clean. I do need to make some adjustments to the foot brake and the belts. I'm also going to make a new handle for my high and low lever. I also want to pull apart my 3-jaw chuck to give that a good clean out, and we need to pull apart our 4-jaw to find out what's wrong with it. And any other problems we find out along the way, we'll fix them up as well. So in the casting, there are plenty of areas and crevices where swarf can get trapped. Using compressed air around a lathe is generally a no-no, because what happens is you can blow swarf underneath your way wipers and it can damage your ways. But if you use it correctly and don't concentrate it in those areas, it can be your best friend. So something else we use are these magnetic wands. These are perfect for getting in hard to reach places and getting material out of the way. Something to keep in mind when you are handling swarf is to have really good heavy duty gloves. Because everything is really sharp, it can cut through standard rigging gloves without too much effort at all.
Whoa. How many jobs was this? 2 jobs.
So cleaning all the swarf and the chips out of a lathe bed, there is no real easy way to do it. There is no point to set up a chip conveyor because manual machines are not designed that way. It is easier just to spend 15 minutes as you need to pull it out and clean it up, ready for the next job. So what I found works best is to pull all the swarf out of the bed, put it on the floor in a pile, and then sweep it up and shovel it in the bin. We also use a magnetic broom to go around the machine to pick up any bits that we've missed. And in case you're wondering, we do recycle all of our scrap metal, including the swarf. It goes from the workshop bin into the main bin, back to our scrap metal suppliers, and gets recycled into something else. So that's all the swarf out of the way, and that's looking a lot better already. But once I've done everything else, I will go through with a heavy duty degreaser and give the entire machine a good clean. Next thing I'm going to do is open up the back of the headstock and remove the bottom cover so we can access the belts and the brake and make any adjustments.
can't make any adjustments with the belts.
So I've just realised we're at maximum adjustment on our belts, so I can't adjust it down anymore and tighten them up, but they're not actually that loose and they're not slipping, so we're going to call them good. But I do need to adjust the brake, so I'll do that now. With repeated use, the brake lining does wear out, and over time you will need to adjust them so everything works correctly, but sooner or later it will need to be replaced. The lining is attached to an adjustment bolt, so I'm just going to crack the jam nut, increase the tension on the bolt, and then lock the jam nut back in place, and we'll give it a test run to make sure it's adjusted correctly. So everything's adjusted correctly and I'm pretty happy with everything in here. So we're going to get this closed up and open up the top of the feed box so we can put some oil in it. So this oils all of the gears for the feed box, which drives the carriage for its feeds and speeds. I'm just going to be topping that up with hydraulic ISO 46. And we don't need to put any oil in the headstock, that is already full, but I am going to open up the top cover just to have a look inside and make sure everything's okay. For those of you who say, you know, you shouldn't be putting stuff on the top of your lathe, if they didn't want me to put stuff there, they would have shaped this as a pyramid so nothing could sit up there. And they do come standard with a rubber mat on top, and that is to encourage you to store shit on it. Inside here is the gear system for the headstock, which is how you set your speed for the spindle. And this lathe has a speed range from 12 to 1200 RPM. So I'm really happy with that. Everything looks brand new in there and everything is working correctly. So we're going to get that closed up. While we're here, we're going to make the new handle for the high and low lever. Because these are just plastic, all it took to break it was just hitting it with the chuck key. The reason why it probably got broken is there was a lot of stuff stored up here on the top of the lathe, and I brought the chuck around so I could have clean access to it, and I've just come around and bumped it, but it did take 4 years for me to do that. I'm just going to remove one of these ones so I have a reference when I'm making the new one. And we're going to be making the new handle out of a piece of black nylon. So this is the only piece of material I have that is black and plastic. It is a little bit overkill, but I'm just using what I've got. So that's done, and that looks a lot better, and after putting it off for so long, it only took 5 minutes. Now we're going to get on to pulling apart our 3-jaw chuck and give it a clean out. So I'm going to remove that off the lathe and get it set up on the bench. So this truck actually came on the lathe. It is a Gator PS3400 and it is a D111 cam lock system. I have never had this truck apart from brand new, so it will be interesting to see what it looks like inside. First thing I'm going to do is remove the jaws. And those are in really good shape, there is no wear on them. We will just give them a clean in the parts washer. While it's up this way, I'm going to undo the 3 main bolts in the middle of the chuck. Now I can flip it over and remove the 6 on the other side. Now I'm just going to use 2 jacking bolts to separate the 2 halves. Now we've got that apart, everything looks pretty good. That green stuff is just grease and there is no obvious damage. And what you can see in here are the 3 pinions. They then engage with the scroll that wind your jaws in and out. So we're just going to keep disassembling this. Next thing I'm going to do is remove the pins that retain the pinions.
Oh. Wow.
Now with the pinions out of the way, we're going to flip it over so we can remove the scroll. That's our 3-jaw chuck completely disassembled. Everything looks in really good condition. The only thing you can see, there is a little bit of staining on the matching faces caused from coolant and moisture being trapped. That's not going to cause any trouble, but overall, everything is fantastic. So what we're going to do is give everything a really good clean, and then we can get it reassembled. And while we're cleaning everything, I also gave the other set of jaws a quick clean up because we'll be installing them when we put this back together. To help remove some of the staining, I'm just going to use a Scotch-Brite pad. And to make sure there's no burrs on the mating surfaces, I'm going to use a set of precision stones to flatten everything off. Now with all that done, we can start the reassembly. So I'm not totally sure what grease was in the chuck. The Jet A one in the parts washer didn't even want to break it down, but I'm going to be using this grease and it's going to be perfect for the application. And on this chuck there are alignment marks on each half, and that was put there during manufacturing, so we want to make sure those are in alignment while we're putting it back together. Now all that's left to do is to fit the chuck jaws, and each jaw is numbered so you can match it with its corresponding slot on the chuck. And that's because the way they are made, the threads are offset over the three jaws, and if you put them in incorrectly, they won't meet up in the middle. And because of the timing of the scroll to the jaws, you do have to put them in sequence, otherwise you'll have the same problem where the jaws won't meet in the middle.
Right.
And something to prevent the scroll from being damaged is I never use a power tool of any nature to wind the chuck jaws in and out. Doing it by hand, you can feel if there is any interference of a piece of material getting galled in the scroll. By using a power tool, you don't have any feel and you can do a lot of damage before you even realize what's happened. So that's our 3-jaw chuck completely reassembled. It's pretty much brand new again. I've also gone ahead and cleaned the spindle nose. Now we can fit the chuck back on the lathe. Now that's back on the lathe, but because we've had it apart, I do want to check to see if there's any run out. So that run out was actually pretty good for a 3-jaw chuck. You're not going to get any better than that. So with this one sorted, now we're going to take a look at our 4-jaw. So this is our Gator independent 4-jaw chuck. Although it is the exact same brand as our 3-jaw chuck, ever since we've owned it, it's been a problem. So this has never worked smoothly. Adjusting the jaws, it is very clunky, and as you are making adjustments, you do run into tight spots. Compared to the 4-jaw on our small lathe or the Shenyang, they run really smoothly and are easy to operate, where this one has just been a nightmare. We bought this brand new with the lathe. It hasn't been dropped or abused, and it's only been used a handful of times. I have removed the jaws and cleaned everything, but it still didn't make things any better. So this is something I probably should have taken up with the supplier straight away, but because I don't use 4-jaws very often, it was quite a while before I even fitted it on the lathe. So what we're going to do now is we're going to completely disassemble this so we can have a look and see what's wrong. Shouldn't be tight.
It just sounds clunky. Oh dear.
Gritty. Broken.
Oh.
Wait, gets worse.
Oh. Oh, I thought we were going to be lucky.
It's the less broken one. So as you can see, when we were winding out the jaws, they were binding, and there is a little bit of damage to the operating screws and the thrust bearings. So because there was so many issues, maybe there was a quality control problem during manufacturing. It could also be this is an ex-demo, or it had been returned to the supplier, because when we turn it over, you can see there are impact marks on the back of the thrust bearings, which looks like it's been apart before. And something else we noticed, one of the thrust bearings is actually sitting about 1.5 mil lower than the rest of them. So that is another sign that this could have been pulled apart, or it was driven in too far during manufacturing. But what we're going to do is remove all the grub screws and remove the thrust bearings. Still swarf in the hole. So our theory that this has been apart before is probably not right, because after we took out the grub screws, we did find there is still swarf down the holes from where they've installed the grub screw to lock the thrust bearing from popping out, which means it's more than likely something to do with the manufacturing.
Whoa. Is that meant to be worn like that?
No, it's supposed to look like that. Actually, not supposed to look like that either. Best one out of all of them. Now that we've got them all out, it is interesting to see that the one that had the thrust bearing seated lower is the least damaged out of all of them. So we can assume that the other three weren't seated enough, allowing enough support onto the operating screws, which has caused all this damage. Something else I'm interested to do is check how hard the thrust bearings and the operating screws are. So I'm going to take a file and see if we can file them.
Uh-oh.
You can file it. So even though the thrust bearing looks like it has been case hardened before, it's actually not that hard. We easily cut that with a file. Now I'm going to check the operating screw. Soft as. So I definitely thought that these parts would have been case hardened from the factory, but clearly they are not. So we have already reached out to all of our machinery suppliers here in Australia to see if we can get replacement parts. Unfortunately, nobody carries parts for these anymore. So we have emailed Gator Chucks in the US to see if they can supply us spare parts. But depending on whether parts are available and what they cost will depend whether we fix this or put it in the bin. So our alternative is we replace this with a new one, but that is about $3,500. So we might just look at going to Heron Forbes and buying a cheaper one for $1,000 and probably have no trouble at all. So while we're waiting for an answer on that, we're going to get back over to the lathe and continue working on it. So I'm going to give this a clean pretty much from top to bottom, and to make that a little bit easier, I am going to be putting Hang Stepper's clean oil straight in the coolant tank. Then I can plug a hose and a brush onto the coolant system and wash everything into the bed of the machine. I've never used this before, so it's going to be interesting to see how good it works. This is coolant safe. It doesn't matter that it's getting mixed into the system, and it's not going to cause any problems. But once I'm done cleaning it, I'm going to drain the coolant tank, fill it up with fresh water and wash everything down. Let that run for a bit. So some of the paint is going to be stripped away, and that's just from many years of using coolant, cutting compounds and rapid tap. It gets underneath it and just lifts the paint. But I'm not concerned about that because that's just something that happens when using machinery. So that's looking a lot cleaner already, and that clean oil worked really well, especially in behind the lead screw where it gets a lot of oil buildup. Now what I need to do is use a dustpan brush, and we're going to pull all of the loose material and the paint into one end of the machine so it can be sucked up, and once we've done that we can suck out the coolant tank. And to vacuum out the coolant tank, I'm going to be using a air vacuum. What it is a air venturi system where air is blown through the valve, which creates a vacuum in the drum. I'm just going to wash the machine down with water to remove any residual cleaner, and then I'll suck out the coolant tank again. Now that's cleaned up, we're going to fill up the tank with water and then mix in the coolant. And the coolant we're using is Hang Stepper's 5030. We've been using it for quite a while now. It is a semi-synthetic vegetable-based coolant. Just like the cleaner, it is also non-hazardous. This coolant uses a 10% mixed ratio. We have about 50 litres of water in the lathe, which means we need to add 5 litres of coolant. One thing I really love about this coolant, it's transparent when it's mixed correctly, which means when you're machining, you've got really good visibility. But over time, when it does get old, it does turn a little bit milky. I'm just going to leave the coolant pump running for a little while just to help mix in all that coolant. While that's happening, I'm going to give the ways a wipe down and spray them with WD-40. Now everything's clean, I like to do this to prevent flash rusting. I use this or ChemTools R56 or inox, but you can use pretty much anything that's going to prevent flash rusting. The last thing I need to do is put a little bit of oil in all of the oilers. Righto guys, so that's all the maintenance work completed on the lathe, and unfortunately we haven't heard back from Gator about replacement parts for our 4-jaw chuck. It has been over a week and we've had no response, so what I've done is gone ahead and ordered a replacement chuck from Heron Forbes that will be here in a few days. That cost us $1,300 brand new, but that was probably going to be cheaper than the replacement parts anyway. So I'm really happy with how the lathe now looks. It probably doesn't get cleaned as much as it should, but it is being used constantly and it is hard to make time to do that. Now all that's done, it's ready to go back to work. I hope you enjoyed the video. Thanks for watching.
Are you right?
I think I need to put more oil in it.
Russell.
Changing gears.
Shut up, Crow. Yep.
Righto. So inside here is the gear system for the... Inside here is the gear system for the headstock, which is... Oh, fuck, I really forgot what I said. And this lathe has a speed range from 12 to... Fuck up, Crow.
Ooh, a slinky.
Now that's back on the lathe, but... Now that's back on the lathe, but before... Oh, fuck me. That doesn't sound right, but because we've had it apart. So it's back on the lathe, but... Oh no, that doesn't make sense. So our alternative... Oh, fuck, I can't even say a word. So our alternative... Stop smiling. Or we could just look at a cheaper version from Heron Forbes for less than $1,000. Did you see that bubble?
I didn't know what that was. I thought it was a bug.
Like a bubble. So that's our 3-jaw...
Start again.
And to remove some of that, some of it, all of it, no, some of it. Right. And to remove some,
Just hold on. It's so annoying. He's talking to a friend out there. Go away, Russell.